This is 7.1.3 least squares, best approximation theorem and normal equation. We discussed best approximation theorem in chapter 6.2.5. Please review this chapter. Basically, in that chapter, we discuss the orthogonal projection, the projection of B onto the space of A will result in the error E equals to B minus B hat, where B hat is equals to the projection of B onto the column space of A. The norm of E square is the smallest among all AX we can choose. Hence, this best solution is called the least squares solution. And this theorem is called the best approximation theorem. This theorem can be understood when we draw a right angle triangle. Remember that the error E, which is equals to B minus projection of B onto the column space of A, is orthogonal to the columns of A. Now the columns of A can be used to form the column space of A, which is this shaded region over here. Now any vectors on this column space is orthogonal to E. We can now view the problem as the Pythagoras Theorem, because if you look at this is a right angle triangle with the red line here as E, and this is the hypotenuse, and the hypotenuse is formed by another point through AX, while this point is through AX hat, the best point that we can achieve, the best point nearest to B. Therefore, it is now obvious that the hypotenuse is length, or the error of approximation is always greater than E, since it is the longest side of a right angle triangle. If you need to refer, please see again 6.2.5 video lectures, which will discuss this problem in great detail. Now we have another equation that we deal with quite often, which is this. The projection of a vector in a column space. In here, the example, the column space W is equals to column space of A. How do we find projection of B onto W? This was discussed in great detail in chapter 6.3.2, the Gram-Schmidt process. For discussion again, please refer to this video. Just now, when we discussed this equation and I explained that this is the right angle triangle. Let's call this point W, a point in the column space of A. This point is the projection of B onto the column space of A. Later in the text, we will also call the column space of A as the capital W. This vector is B minus W. W is this W here. This vector is projection of B onto W minus W. And this vector is B minus projection of B onto W. Now, compare this to the equations over here, and you will now understand that this is the Pythagoras Theorem. The longer side square is equals to one of the side square plus the other side's length square. And read the rest to complete the proof, which says that when we project B onto W, the error found is the smallest among all the errors we could ever achieve for any W.